What if life in our solar system doesn't just exist on Earth? What if right now, in the freezing darkness of space, tiny alien creatures are thriving beneath a thick layer of ice? They wouldn't be living on some distant planet in another galaxy, but on a tiny moon orbiting Saturn. This is Enceladus. At first glance, it's nothing more than a frozen snowball floating in space. But beneath its icy crust lies a vast global ocean, an ocean that might just be the perfect cradle for alien life. In today's video, we're going to explore everything we know and don't know about this strange world, the discovery of its geysers, the shocking secrets revealed by NASA's Cassini mission, the possibility of thriving ecosystems in its dark waters, and the future missions that could one day confirm if we are truly not alone. Stay until the end, because some of the latest scientific findings suggest Enceladus could be an even better candidate for life than Mars or Europa, and the truth might be far stranger than we can imagine. Welcome to Orbital Vistas, where we journey across the cosmos to uncover the universe's biggest mysteries. If space exploration, alien life, and mind-bending science fascinate you as much as they fascinate us, make sure you hit that subscribe button and ring the bell, because you won't want to miss what we're about to uncover. And here's a challenge for you. By the end of this video, you'll have a new perspective on where life might actually exist in our solar system. Drop a comment with your theory as you watch. We love reading your thoughts, and we'll pin the most intriguing one under this video. Enceladus was first discovered in 1789 by William Herschel. But for over 200 years, it was little more than a faint dot of light in telescopes. One of Saturn's many moons, just 500 kilometers across, about 1/7 the size of our moon. For centuries, scientists assumed this tiny world was geologically dead, frozen solid, and utterly lifeless. Fast forward to 1980 and 1981, when NASA's Voyager spacecraft flew past Saturn. Voyager gave us our first close images of Enceladus. Even then, it stood out. While many of Saturn's moons were heavily cratered and ancient, Enceladus appeared unusually bright, with smooth regions that suggested some kind of resurfacing. Something was shaping this moon. But what? Still, Voyager's brief flyby couldn't answer the big questions. It wasn't until NASA's Cassini spacecraft arrived in 2004 that Enceladus truly transformed from an icy rock into one of the most exciting places in the solar system. In 2005, Cassini made a close pass over Enceladus' south pole. And what it found shocked everyone. Massive geysers, shooting plumes of water vapor hundreds of kilometers into space. Imagine a world so cold that its surface is frozen solid, yet it behaves like a gigantic icy volcano, spraying material out into space continuously. These plumes weren't just water. Cassini detected ice particles, salts, and organic molecules, all being vented into Saturn's E-ring, which Enceladus actually helps to replenish. This was the first undeniable sign that beneath Enceladus' icy shell, there was liquid water. Scientists were stunned. The conditions required to keep water liquid so far from the sun seemed impossible. Yet, here was proof. A moon with a hidden ocean in one of the coldest parts of our solar system. Through multiple flybys, gravity measurements, and magnetic field analysis, Cassini confirmed what had only been speculation. Beneath Enceladus' frozen shell lies a global ocean of salty liquid water. The ocean is estimated to be tens of kilometers deep and in contact with the Moon's rocky core, an essential detail for the chemistry of life. And thanks to Saturn's immense gravity, Enceladus experiences tidal fluxing, where its interior is squeezed and stretched. This generates heat, enough to keep water liquid and even drive hydrothermal activity on the ocean floor. Picture this: vents on the sea floor releasing hot, mineral-rich water into the dark ocean. On Earth, similar vents host thriving ecosystems with microbes, tube worms, and even complex animals living without sunlight. If it can happen here, why not on Enceladus? Astrobiologists often say life needs three things: liquid water, a source of energy, and the right chemistry. Enceladus has all three. Number 1, liquid water. A massive global ocean beneath its ice. Number 2, energy. Hydrothermal vents powered by tidal heating, providing chemical energy. Number 3, chemistry. Cassini discovered organic molecules, salts, ammonia, and molecular hydrogen in the plumes, all essential building blocks for life. In fact, Cassini detected hydrogen gas specifically, which on Earth is used by certain microbes as a food source. If those microbes existed on Enceladus, they could be living just like Earth's methanogens, feeding on hydrogen and releasing methane. It's a tantalizing possibility, not just life surviving, but life actively thriving beneath the ice. In its later flybys, Cassini made its most groundbreaking discovery yet: complex organic molecules, far larger and more intricate than scientists expected. These molecules are the kind of precursors that, on Earth, lead to amino acids, proteins, and eventually life. Combined with hydrogen gas and warm water, this means Enceladus has all the same ingredients that made life possible on early Earth billions of years ago. The question is no longer, could life exist here, but rather, why wouldn't it? And here's where it gets even more exciting. Unlike Mars, where we'd need to drill or dig to find water, Enceladus delivers samples straight into space through its plumes. Any future spacecraft could simply fly through them and directly test for living microorganisms. If life exists on Enceladus, what might it look like? The most likely candidates are microscopic extremophiles, tiny single-celled organisms feeding on hydrogen and minerals, similar to bacteria around Earth's hydrothermal vents. But evolution has a way of surprising us. Over billions of years, could these microbes have formed more complex ecosystems? Tiny worm-like creatures? Jellyfish-like beings drifting in the dark? Maybe life here doesn't even use carbon or water the same way Earth life does. It might be silicon-based, ammonia-breathing, or something entirely unknown. The possibilities are mind-blowing. And we may be only one mission away from finding out. NASA and ESA have proposed several future missions to return to Enceladus. The Enceladus Life Finder would fly through the plumes again with better instruments to detect biosignatures. More ambitious ideas involve landing on the icy surface or sending a cryoboat, a robotic probe that could melt through the ice and release a submarine into the alien ocean. If funded, these missions could launch in the next decade or two, making Enceladus one of the first places beyond Earth where we might directly confirm extraterrestrial life. Enceladus is tiny compared to Earth, yet it may hold the greatest secret of all: proof that life is not unique to our planet. If alien life exists in this icy ocean, it changes everything: our understanding of biology, evolution, and humanity's place in the cosmos. So what do you think? Are we just one mission away from finding alien life? Drop your thoughts in the comments. We'll pin the best theory below. If you enjoyed this journey to one of the most fascinating worlds in our solar system, hit like, share this video with a fellow space enthusiast, and subscribe to Orbital Vistas for more deep dives into the wonders of space. Because one day, a tiny icy moon might give us the answers to humanity's biggest question: are we truly alone?